Okay, so finished up everything and did an initial build. What did I do? Let's see. I did add a require greater than check just to check an assertion to make sure that whatever amount is passed to mint supply is valid. Other than that, when I ran the anchor build and whatnot, everything compiles, but I'm getting these new warnings. Seed path, unexpected seed category. In a quick Google search, seems like when you do seeds equals true to enable Anchor's PDA inference feature, that this can come up. I'm not entirely sure where exactly this is coming up. Here in my create entry is where I do the entry count +1 to create a new entry. I do that sort of thing, and when I try to recall a new entry to create an entry and derive the PDAs and whatnot, I am using the ledger's entry count but +1. So I think there may be a better way to do this, but that's for another day. I'll look into that a little bit more. But everything compiles. We're back on the local test validator for now, and I now need to create some tests. Oops, wrong file. I have my ledger test file here, where when I was doing the dApp token manager approach, I was still grinding a new key pair file and doing that approach. But now that I've found this easier solution where you are going for the easier route for now until I really need something a little bit more robust. So here we are. I have my screen split. This is the top over here. And yeah, so here's some leftover stuff. Test token mint, and then a dApp token manager seed prefix. I was doing all this kind of stuff. But I think we're going to get rid of this stuff. Yeah, because I'm no longer going to use the dApp token manager. So one of the things I do need to do in order to make this work is, because we are using a PDA for the mint, it's time from the client side. I need to actually derive this PDA. So I think I'm just to do it up at top. I need it up at the top in my tests so it's accessible throughout. I plan on creating multiple tests, obviously one to initialize the mint, and then some additional ones to mint supply. And I'm keeping my older test still here using the local key pair, just because they're good tests, and that's another approach. So I don't want to completely scrap those. But for now, let's I'm going to call this the dApp token mint PDA. And this is our typical find. They have it sync now. That's the updated approach. And so my seeds, we have the buffer from, and I call this dApp token mint, and that's it. So we have the seeds that we're going to use as dApp token mint, and then we need our program ID, which again, our program comes from Anchor's workspace. And so thank you, Anchor, for making this just a wee bit easier. So program ID. Yeah, So that does not exist on type of import. Where am I getting that from? Find program. It's not Web3, it's public key dot. There you go. That's the problem with splitting my screens. I can't read everything. So let me go ahead and close this out. So yeah, here it is. Just the typical standard derive the PDA. But this time we're using our buffer, our seed, dAppTokenMint, along with our program. And then we're going to use this address to be the address for our mint, as well as its authority. So I'm going to go ahead and log this like usual. Dapp do the PDA. So this will give us our new, I'll do to base 58. So this will be essentially our mint. So this would be the token mint for our application. I mean, simple as that. And I don't have to really do much else because, scrolling back up, because to initialize this thing, we saw in our instruction that it really is, everything's just done on chain. So that means we can invoke our method right now. So it's just a typical const transaction, right? So we're going to await program methods. Create dApp token. It should be create dApp token mint. Yeah. You know what it is. I don't have the correct update on my IDLs. Yeah, so I made a mistake. So back in my lib.rs file for my program, when I was adding these two new instruction functions, entry points, I did not type it all the way. So createDappTokenMint is what I mint. So now that I've saved that, I need to go back and rebuild. And I'm going to go ahead and shut down this. And let's rebuild this thing again. Now we're going. So this particular createDappTokenMint, there's nothing to it. So there's really not much I need to pass. I don't have to pass any sort of token accounts or any sort of accounts because everything can be inferred thanks to Anchor and the seed's true component. So if I do RPC, I know, do like skip pre-flight true. And then let's console log the transaction. And that is honestly like all that's needed. I could do something like check the, just verify that there's something, that's been initialized using the get mint and here we use the provider.connection and then our dAppTokenMint PDA. Now with that, we should then be able to get mint. I need to import it. And now we should be able to see console log. Yeah, something like that. I'm gonna close this down. It's hard to read. It's trying to keep the font size large enough so everyone can read it, but the global state, yeah. So I have my global just dAppTokenMint, yeah, and we're gonna just update it. The reason I'm doing this is because I want to be able to run some checks on here. So I need to make sure that dAppTokenMint, its address, and when we're dealing with public keys, we have to convert to strings. So let's make sure that it's that's the same. What else can I do? I want to make sure that it's decimals is, let's say decimals should be 9, right? Hold on. So next we're going to do the not initialized. I guess I could. I guess I could do that. What else? Really the big thing that I want to change. That's helping me out. Not null. I don't want the mint authority to be null. I actually wanted to make sure that it also equals the dAppToken PDA to. So we're using the exact same PDA address to store the mint account as well as the. Don't need the supply just yet. Well, I guess we could do that. Nah, I don't need that just yet. What I really need is I want to check out the freeze authority as well. Yeah. And so, honestly, after this, you have, if all goes well, this is all that's needed. I don't have to, again, I don't have to pass accounts to this instruction because Anchor infers a lot of the kind of necessary accounts needed. So like the token program, the system program, the rent sysvar, there are no unique accounts needed for this because we've specified all of what we needed inside of our validation structs. So Anchor is smart enough to kind of derive everything that's necessary. So this right here should create our dAppTokenMint at a PDA, and we are good to go. There's no need to derive any sort of key pair file or to generate a new key pair. This simply, and also prevents, we don't have to do anything really from the client side. We don't have to use the JavaScript library to create Mint in that sense. It's all done for us on or inside of our program on chain. So super handy. All right, so let's run our tests. Got it built, and now we just need to, at the very least, we should be able to initialize a PDA mint associated with our program ID. So let's do anchor run test ledger. I don't need to test everything else. I've only deployed the ledger. And yeah, looks good. So yeah, so here we are. There are a lot of tests that are being done here, but modify, create that, create ledger test, create, but createDappToken, this test right here. So what we have is we have our transaction went through. We created a current DappTokenMint. Here's our pub key with 3TZ whatever. And then you'll notice that the mint authority is the same right here, which is the PDA address. And then the freeze authority, which is again all set inside of our program, that's the same PDA. It's initialized, decimal is 9, 0 supply. So our first test, our first little test with this works. So technically, if I wanted to leave the validator running, what I could do is put an X here, and that triggers to Chai and Mocha testing framework just to ignore this unit test, and instead, just skip it and keep going. Because I don't, technically, when we move this over to DevNet, we just need to run this one time. And that's just part of our deployment, really. You deploy your program to DevNet, and then the next step would be, in the deployment, would be to deploy this createDappTokenMint, basically, to run this function and have that go through and paid for. We, in this case, we're using the wallet that's the payer, essentially, for this transaction is the provider wallet, so which is just my default local wallet for now. But things you can change that, who wants to pay or who you want to pay after you deploy on DevNet. So this first test is good to go. What I need to do next is create a test for minting new supply. So let's call this mint DappTokenMint to user, and we're going to do create the. Again, this is using Anchor's feature, a init if needed feature. So super helpful there. So let me see real quick. I'm going to split this. What do I have at the top? I need a wallet for this. I think I'll use user2 wallet. Because I think all my previous tests have just been involved with user 1. Yeah. So, oops. So let's do it. What we need is, because we have to potentially create a new associated token account, our init if needed it's going to all happen inside of our program. That said, we still need to derive that associated token account address. So to do that, well, let's get the we can do. I think I've got a user2 token account. I believe I have that. We need a token account to work with. I've got a ledger. Maybe I don't have. We have an authority token account, but that's for our other tests. So, Alright, I'll do user2. And this is going to be of type pub key. Something that we can use and refer back to. Okay. And what we will do here is the await get associated. Don't need to do the get or create because that's essentially what our init is. Is it get associated? pretty sure it's that. Let me look in the documents. Let me find this. Yeah. Okay. So it's in the Solana SPL token docs. So it's this function here, get associated token address, where you pass in the mint pub key, the owner, which would be the wallet address, and then there's a couple other options. So yeah, this is just getting the account, which is what we need because we're using our mint PDA along with the user's wallet to essentially find out what would be that one unique associated token account with this mint for that user's wallet. And once we have that, then we can use it to, to execute the rest of our what we're trying to do. So let me see. I feel like there's a sync version of this. So let me go up here and let me see. Get associated token. Async version of get associated token address sync for backwards compatibility. Yeah, I'm not sure. I think they are moving to the synchronized version. So with that said, we need the mint, which we have as the dAppTokenMint PDA. And we also have the wallet, which is going to be the owner. So we're using user2 wallet.pub key. Yeah. So this is going to be the owner and our mint. Okay. So we now have a unique ATA address. Time to build up our transaction. So const tx, and again, this is using our own custom program method, which is mintDappTokenSupply. And this one does have a, not method, but methods. Does have instructional argument data. So what that means is that it has the amount that we need to pass. So like how much do we want to mint to the user? And I think I'm misspelling this. Methods.mint. Yeah, lowercase. My bad. Here we go. Now we're getting some help. So everything is the same except for it does accept an amount argument, which because it's type U64, so it's an integer of type unsigned 64, it's a large integer. So with TypeScript or JavaScript, it can't use number, the primitive number type. Instead, it has to use the anchor bin. So we have to kind of convert it to anchor.bin. And then inside of here, we can pass in. So I think I have a mint supply raw. Yeah. Something like that. And in fact, I'm going to clean this up. Next, we have the usual, our accounts. So we have the token program, rent, system program, the mint, the user token account address, all these things. A lot of them, thankfully, Anchor handles, but let's just do it. So the user token account should be user2 token account, yeah, which we are deriving up there. The mint is going to be our dAppTokenMint PDA. User, it's going to be the wallet. Oops. I don't know why it's trying to user. Let's try this one more time. User to wallet public key. Okay. Associated token program. I think I have. No, I have not. So. That should help. It's not called user token, it's just called user token account. All right. And then we have to sign it. So signers. So let's think about this. This is using in our program the init if needed. So if there is a wallet, and we talked about this previously, if there is an account that needs to be created, then the wallet, this user wallet, needs to pay. And I think that's it. The mint has been initialized. There's no other account that would be potentially paying for this or created, so I think we're okay. And then last, do our usual RPC call. So I think we're getting there. Cannot find name. Oh, that was outside of the function. So at this point, we should have an account created. So I may end up, I'm not sure if I really need to do this in a try catch. I know that sometimes doing async calls may be better wrapped in a try catch. So let me actually go ahead and do that. So I'll just start up here, try, and I'll just log the error for now. This will at least have something for us. So if this works, if we get through that and our transaction goes through, then it's a matter of, all right, we need to do some testing. So we need to, let's get the current dAppTokenMint. Just curious again, so just like we did before, and in fact, I'm going to copy this code. So where did this whole part, it's updating our mint and then updating the global state account, the variable that I'm keeping track of. But now we should have minted supply, which, what did I put it at? Yeah, I think 10,000 is what I was going for originally, so why not? We can try it. It's flexible. But one thing I do want to double check is, let's see what the supply is. So supply this is going to be, well, I mean, this dApp token mint dot, it has quite a bit of properties. So the authority, the supply is what we're after though. And if we look at this, it's type BigInt. So this means it's a little bit, there's a couple of things you have to keep in mind when working with type BigInt. Because I want to essentially, I want to make sure that it equals 10,000. Because when we pass in here, what we pass in for amount really represents the raw amount in raw units with the decimals included. So it's a big number. Hence anchor big in the BN type. So what else we have? Value of toString, local toString, value of. Yeah. So let's do, it's going to be dAppTokenMint.supply, which is BigInt. And if it's 10,000, I need to divide it by initial raw token supply. That's for a different setup. Mint supply. Then I'm going to create another variable called like dApp token dApp. Let me just call it one token amount raw. Yeah, which is really this 1, 2, 3. Okay, so this is one token. Okay, and then if I take this mint supply raw, whatever this value is, and divide it by the one token amount raw, I should be able to get the same number. And these are large numbers, so I have to use BigInt to do that. So, I think you can like interface BigInt constructor. So I think you can do, so we have like a BigInt divided by a BigInt. Yeah, I think. So one token amount raw. But one of the things about BigInt that I do know is that, so BigInt looks like, it'll look something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then like this in on the at the end. Obviously I don't want that, so I believe there is a toString that we can use. Oops. I'm gonna go ahead and close this down. So it does the math, arithmetic between two BigInts, and then you can do the toString. I feel should be 10,000. That's what I think, what I hope. No guarantees. So anyway, so that's the supply deal. I probably should print this out. Console log. We'll test it out. And all of this is really to say, I want to just double check that the supply actually equals this. Yeah. So change this to string. Just so I know what I'm talking about. Let's get the user's token account info. User 2. Could get the balance, but I want to make sure that the token account's mint property is equal to the same as my dAppTokenMint. So need to get a little bit more info, and that can be done using the get account. Well, it's actually probably gonna wait. Get account. This has got to be another. Let's go back up here. Freeze account. Get account. Yeah, it's just right here. So this is retrieve information about a token account. Again, thank you, Solana devs. So get mint. Let's do get account. Yeah, should be okay. There's quite a few ways to do this, but this one's going to give me quite a bit more information. It's going to return the token account info, which will have a lot of the properties, so I can use that as in my test. So what do we need here? We need a connection and the address of the token account. And then there's some other stuff you can pass, but we just need, so connection would be the provider, connection, and then our user token account. Yeah, it's a public key, so that's that. So we have that. I feel like we can basically just time to use our expect. So what do we expect here? All right, well, let's just I think what we could do is expect the, yeah, let's start with the supply token mint. So, well, let's expect the token mint supply to be what we just calculated up top. So I don't really need maybe toString to equal. Can I do supply UI? So divided by that. No, that's not going to be right. So it actually needs to, this needs to be like 10,000. Can I do this? Will that work? Oh, I think it's like parse int, parse. Hang on. How should I do this? How should I do this? I think perhaps maybe we need another variable. So if we have that, if I have a mint supply UI to string. Am I doing that right? So let's see, we'd have I feel like I'm missing. I feel like I'm getting a little confused with the math. Hang on. All right, hang on. I'll come back to this in just a second. Let's do the easier ones. It's not like this is hard. I'm just these raw amounts versus these UI amounts tripping me up a little bit. So user2 token account. Don't do that. Don't do that. Token account amount. It's not. That's not right. Expect. Thank you, GitHub Copilot. You're trying to help, but in this case, not helpful. So token account info, and what do we have? We have the amount in which is BigInt. So that's going to be the raw amount divided by BigInt 1 token mint raw. But I need to wrap this up. Hang on. So that. So if that divides, so if we have the raw amount, should be 10,000, but the raw amount will be to, base 10 to the to the power of 9. So then we have this massive raw amount, but we're trying to simplify it for the UI, which means we can turn all that to a string, and we want that to equal, well, what do we want it to equal? We want it to equal we want it to equal the mint right? Feel. What is this yelling? Cannot find name mint amount UI. What did I call it? Oh, mint supply. Or I could rename that. I think my math is possibly wonky. I think this one's needs a little bit more work. I think it's the exact same thing, actually. I'm just overcomplicating it. So, but last we need, what else do we want to check? I want to check that for user2 token account info. I want to check that the owner, and because it's a public key, can't compare those directly, so we have to use convert it to strings to equal, and then what do we, obviously this should use the pub key to base 58. Yeah. I would also say the mint, it's a pub key, again, to equal, what do we want it to equal? Well, we want it to equal our dApp token mint, PDA, like the address. Yeah. I could do dApp token mint address dot to base 58. That also works. So, yeah. Anyway, yeah, I think that's essentially what we're looking at, I think, let me fix this darn thing real quick. So expect, we want our dAppTokenMint supply. It's going to be the raw amount. It's going to be the raw amount. So it's very similar to what I did up before, divided by BigInt. Obviously, this, I'm seeing a lot of repetition here. 1 token amount raw. That is okay. And let's find 2 raw. And we're going to change this to string. Okay. Now, on the next line, what I need this to be the expect. Yeah. So here is my expect. Okay. And we're going to have it, I really could like do something like that. Ugh, ugly. To equal, and then the mint supply UI. Right? That should be my 10,000. Yeah. But because we're comparing BigInt to BigInt, we have to ultimately pull them into some strings. Okay? And I believe, fingers crossed, that should do it. Now, I have not shut down the validator. So perhaps if I were to go over here and rerun, let's see. This may not work this first time. Oh yeah. It broke right away. All right. Let's address this. Problem is with my ledgers and entries and whatnot, they're PDAs as well, and by trying to rerun this again, they're gonna have some issues because those have already been created. So let me start it over. And rebuild everything. Do some logs going, and maybe we'll get lucky this time. So again, we're just looking at the ledger test for now. Everything should work. I'm not sure about the last one. Oh, look at that. So I forgot that I did one pending, which is the main one, the one that is supposed to actually create the mint. So I was showing you that and I forgot. I actually made that change. All right. One more go. So I'll get the logs going. And then anchor build and deploy. We got those seed warnings. I'll look into that. And then our test. 3rd time's a charm. Let's get lucky. Hey. We did it. Yeah, super cool. So, we can see, yeah, this last test is our mintDappTokenSupply to user2 wallet and create the ATA if necessary. And here are the stats. So supply UI amount string, I was right, 10,000. The mint authority has this. So all the current dAppTokenMint object has a lot of data. Supply being a BigInt, so it has the in at the very last spot. Decimal is 9. It's initialized. Freeze authority. Again, you see our 3TZ PDA address is used for our mint authority and the freeze authority, as well as the address for the current dApp token mint. The public key is the exact same. So super easy, man, super easy. And what do you know? Our math worked out okay. So we have the correct amounts for our tests. So what I need to do next, I mean, this is great. It's going to mint. What I'd like to do is copy this one more time and just ensure that we can, again, and I'm going to do ATA already created. So this is, it will still send this over, but we should not have any issues with, you know, the ATA has already been created, so we should not have to do that. I'm going to mint the same amount of supply, so 10,000 to the same user. Get all of our updates. In this case, it should have supply UI amount string. I never really did anything with this one, but this one just updating should be 20,000 for our token supply. Yeah. And here, dApp token mint supply divided by 1 to string should equal mint supply. I'm going to do something like this. Times 2. Right? It's our second time to mint supply to this user. And the amount that they have, same thing. I can do wrap all this, do it times 2. Check. And everything else, I don't, you know, it's kind of, oh, wait. Did I just mess up my code? Ugh, I did. Stupid. Copy pasted. Ugh, bear with me. Let me do this real fast. Okay. Did that. I've got the exact same test, just times 2 essentially. A little bit of redundancy, but oh well, that's for testing. So, and I've rebuilt everything. Got the logs listening, so let's do it again. So anchor run. And this time, if our math works, if I did it correctly, then everything should pass. Yeah, so now our amount, our supply, total supply is 20,000. The user's token account has 20,000. And the ATA, because it was already existed, it did not have to be created thanks to that feature. So that's looking good. I think next really is getting this thing to deploy on DevNet. We need to take this, the tests are working, our simple program instructions are working, accounts that we need seem to be working. Everything seems to be okay so far with these tests. So my next step is to merge all this stuff with my other branch, my main branch, get this stuff going, and then deploy all of these changes to DevNet, so that on DevNet I can, rather than having a setup button, I can have something, or I could replace that. I could have another button called, initialize dApp token mint, just for me. So I deploy the program and run this new code. It will have a token supply available that should, in theory, work. Now, one thing that I'm going to have to do as I'm talking through this is that I need to make some slight changes to how I create new ledgers and the logic there. I want this functionality. Specifically, after initializing the token, I want to use mintDappTokenSupply inside whenever I do a CreateLedger. So that handler function that I have that handles this CreateLedger right here, essentially, and that's involving a little bit of SvelteKit form actions and whatnot, but that handler needs to not only create the ledger, but you also run this mintDappTokenSupply for the connected wallet. Yeah. So I need to think on that a little bit. I may have to add a new test here locally before I actually try to push all that. So, but in essence, we have the instructions working out, and we have some tests, and so I'm feeling pretty good. And this was quite a bit easier than my other approach.